Now we are going to see an example for LERS, and you can find this is our system S, which consists of terms A, F, and G, and the certain and the possible rules are represented by C, and C consists of set X, S1, C1 and C2, which consists of X2, X3, and X1, X4, X5, and X6. Moving on to the next slide, we progress with the step one. First, we look for each set, which is about the subset of C, which is either C1 or C2. So we write down each of the remaining sets by looking at the table. For example, when considering the column A, we find that it consists of sets A1 and A2, and for F, it's F1 and F2 and so on. Then we start checking if any of them are subset of C, and we mark them. We recall that the set A is a subset of C, as you can see, because A consists of 1 and 2, which is a subset of B because B consists of 1, 2, 3, and below are the steps for the first loop. And we move on to the step 2. Next, we generate rule from the sets in the first loop, which have a decision attribute C, which is represented as C1 and C2 on the right hand side. We create certain rules from the marked sets above and possible rules from the unmarked sets. The rules which are certain have a confidence rate of about 100%. That means that means that sets will happen for sure. And if so, if a set is marked, for instance, A2, because A2 is a subset of C2, then we create a certain rule that A2 tends to C2. For possible routes, we need to calculate the confidence according to the Agarwal method. If a set is not marked, for instance, we consider that A1 is not marked, then A1 can possibly imply any of the values of decision attribute which tends to C1 or C2. So we create a rule A1 belongs to C1 or A1 belongs to C2, and next calculate the confidence of each. As you can see that when we consider A1, the confidence rate when corresponds to 50-50 in the below steps. And moving on to the step 3, if there are any unmarked sets in the first loop, then we go to the second loop by combining the unmarked sets together. That is, we go to two element set. For example, since A1 consists of X2, X3, X4, and X6, and G1 consists of X2, X4, where X2 and X4 are common in both the elements. So finding a union of A1 and G1, we get a set of X2, X4, which is a two element set. And we check if there are any two elements set we generated or marked. If there are no unmarked sets in the first loop, we stop. Otherwise, we move on to the step 4, where we check if there are any unmarked sets in the second loop, that is in the step 2, and we repeat the step 3 again. And this process goes on until we mark all the sets. And this is the process of LERS. Now, the LERS are being used in finance industry to decide whether to give loan or not, and in medical industry to support diagnostics, and in military for evaluation of job performance. Now, the question regarding the LERS example is that, can LERS system only compute rules for perfect data? Tell me whether it is true or false. The answer is false, because LERS system is used for both perfect and imperfect data, as it can generate rules which works with inconsistent data also. Thank you.